Relative values, it's a type of problem solving that comes up quite a bit. I think it's quite easy and they give you good marks. Let's see. The classic relative values question. Anne is twice as old as Brian. Brian is 4 years older than Colin. The total of all the ages, Anne's age, Brian's age and Colin's age, is 32. How old is Anne? The first time you look at this, it's going to look dreadful. Well, the second time's not good either, but by about the third time, you'll see that there's a pattern to these sorts of questions. So what do I think about first? What is the equation here that I have to solve? Well, after I've thought about it, this is the common denominator of all these questions, that we know the total of the ages or whatever is being counted. So we know that A plus B plus C equals 32, where of course this is Anne's age, etc. We then look for other equations, and I notice that Brian is mentioned in the first two sentences. So I think Brian is going to be key, and I'm going to try to find A and C in terms of B. Then I can add up A, B and C, and I can find what B is, and hence I can find what everything else is. Right, let's see how that works. The first sentence, Anne is twice as old as Brian. A equals 2B. Brian is 4 years older than Colin. Brian is C plus 4. Right, well this gives me A on its own, but this doesn't give me C on its own, so I'm going to have to subtract 4. B minus 4 equals C. I now have A on its own in terms of B, and I have C on its own in terms of B. So going back to that original equation, A plus B plus C equals 32, I can replace A with the 2B. I can replace B, well that's just B, and I can replace C with B minus 4. Brilliant. That still equals 32. So I can collect all the terms here. 1, 2, 3, 4 B's minus 4. 4B minus 4 equals 32. I think you can see where this is going. We'll add 4 to both sides. That's 4B equals 36. And now divide by 4 to give me B is equal to 9. Now I've got B, I can get the rest. A equals 2B. Anne equals 18. Lovely. Quite enjoyable, that one. Of course, we're going to have to check it. Let's get all the values out. A is 18, B is 9, and C is 4 less than B, so that's C is 5. And of course, I want to check A plus B plus C is equal to 32, and indeed it is. So I'll be very happy with that. I have a think about it. I dig out the main equation that they all add up to 32. I work out that Brian is going to be useful. I can express Anne and Colin in terms of Brian's age. So I can add them all up and find B. I can do it and I can check it easily. Lovely question. Here's another example. Roger is 4 years older than Sue. Sue is twice as old as Tom. Sum of the ages is 34. Right, well we know where this is going. The sum of the ages is 34. Roger, Sue and Tom equals 34. Sue is in both sentences, so I'm going to express Roger and Tom in terms of Sue, and then I'm going to add them, then I'm going to find what S is. So Roger is 4 years older than Sue. Roger equals Sue plus 4. That gives me R on its own, so that's good. Sue is twice as old as Tom, so I divide by 2. Not particularly happy with the half S, but I have to live with fractions sometimes. I've now got Tom on its own. So I have Roger on its own in terms of Sue. I have Tom on its own in terms of Sue. So Roger plus Sue plus Tom equals 34, and I can replace these. I can replace Roger with S plus 4, Sue with Sue, and T half Sue. And it still equals 34. Right, be careful here. S plus a half S, 2.5 S, plus 4. S plus 2.5 S plus 4 is 34. Right, we'll get rid of this 4. No, we won't. We're going to multiply first. Times by 2. Get rid of this half, which will give me 5s plus 8 plus 64. Don't forget, you multiply all of both sides. So not just the 2.5 by 2, you multiply the 4 by 2 as well. Subtract 8. 5s is equal to 60. Oh, this is a nice round number, isn't it? Divide by 5 and s is equal to 12. So s is equal to 12. What else do we have? Well, we're looking at, let's get all the ages out. So R is equal to 16, which is S plus 4. S is obviously equal to 12. And T is equal to half of S. Sue is twice as old as Tom. So T is equal to half S. T is equal to 6. And we're asked to find the ratio of Roger's age to Sue's. Roger to Sue's. Is that right? Find the Roger's age to Sue's age. Oh, we're finding the ratios to all of them. R to S to T equals 16 to 12 to 6. We do not need to divide by 2. You could, because the same ratio is 8 to 6 to 3. But you don't need to, because this ratio is correct. Some people like to, it doesn't say in its simplest form, this ratio is fine. Let's check R16, S12, T6, add them all up. R plus S plus T equals 34, which is what we want, and all the conditions apply. So I'm very happy with that. So what did we do? Had a think, saw we have a total, saw that we have Sue in both of the other two equations, so we'll get Roger and Tom in terms of Sue. We did all the calculations. We then checked back to see what they wanted. Sometimes they want an age. Here they want the ratio of all of them. Bit much, but there we go. 16, 12 and 6. And then we checked it. Thank you very much. Sometimes they're a little bit tricksy. And this brings me back to the subject of taking something which is a real world thing, if you believe these people exist, it's real world, and making it a little abstract. Because here we don't have the total of their ages. And we don't have, well, we're given what Edward is, it's this strange K. And we don't even find all their ages, because all we're looking for is a formula for Y in terms of K. Now, I hope we're in the groove, because we're going to do exactly the same thing. We're going to have a think. We're going to see that the total is Y. We don't have numbers for here, but we know that Edward plus Frank plus Greg is Y. First opening gambit. We also see Edward is K, right? Frank is 2 years older than Edward. Greg is twice as old as Edward. Edward features in everything. Nice. So I am going to find E, F and G in terms of K. But I'm going to do it using the fact that they are the same as, well, they're related to Edward, and Edward is K. They haven't made it that difficult for us, thankfully. And then we're going to add them all together, and we're going to find the formula for Y. So we start off, Edward is K. That's easy enough. Frank is 2 years older than Edward. F is Edward plus 2, and we know Edward is K, so that equals K plus 2. Lovely. Greg is twice as old as Edward. So Greg equals 2 Edwards, but we know an Edward is worth a K, so that's equal to 2K. We now have E in terms of K. We have F in terms of K. We have G in terms of K. And we have this lovely equation here, which adds them all up, and we get Y. So now we have E plus F plus G equals Y. And that is going to help us, because the first one is E is K, F is K plus 2, and G is 2K equals Y. And we total this up. K plus 2K is 4K plus 2. 4K plus 2 equals Y. We never get the answers, as we have in the previous questions. We never get the actual ages. But all they wanted was a formula for Y in terms of K. Brilliant. I like that. Can we check it? Tricksy to check it because we don't have numbers, but we can eyeball the calculations, and if we do that we'll probably find that they are perfect. I'm very happy with this question. This is an example of a sort of real world situation, but being made abstract by not having the starting ages and not having the total ages. So we did the same as before. We thought about it. We saw that the 3 ages add to Y. We stated that, and we found all of the ages in terms of something common, added it all up and found a formula. And we did the calculation and checked it as best we could. Right, here it comes. The method hack. What did we do? What's the first thing we look at? We look at the fact that we've got the total of the ages, and that gives us this basic formula, A plus B plus C equals 32. We also have 2 statements involving a key age. Brian's very popular, is in both of these sentences. So we set A and we set B, we'll eventually get both of those in terms of Brian. We put the values into a total equation, 2b plus b, b minus 4, and it equals 32. And then we use that to solve the key age to find out that b is equal to 9. And then the rest. We can easily find what the other ages are. And of course, we check it. And this is the big check, really, that all the ages add up to what we think they should add up to, whilst also follow all of these other criteria. Brilliant. So I hope we've taken a tricky question and made it easy. I'm not sure it really gets too easy. I think it's still tricky, to be honest with you. I might change this graphic. It's not as tricky once you know what you're doing. Anyway, stay with me, please. If you want to pass your exam, I've got loads of ideas. Subscribe and stay around. Anyway, if you're taking the resit in November, best of luck.